Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about trends in the periodic tables. So, I will discuss about ionization energy, atomic radius, electron affinity, electron negativity. So, size of atoms. The bonding atomic radius is defined as 1/2 of distance between covalently bonded nuclei. Look at here, distance between nucleus, atomic radius and nucleus. So you have the hydrogens, oxygens, nitrogens, fluorine, chlorine, bromine and iodine. Now you can look at the atomic radius 30 pm and 66 pm, 70 pm like that. So atomic radius trends. Group trend, as you go down a column, atomic radius increases. As you go down, electrons are filled into orbitals that are farther away from the nucleus. Attraction not as strong. So periodic trend, as you go across a period, left to right, atomic radius decreases. As you go left to right, electrons are put into the same orbitals, but more protons and electron totals, more attraction is equal to a smaller size. So you can see here, hydrogens, lithium, sodium, potassium, beryllium, magnesium, calcium, and then you can see boron, aluminum, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, neon, argon. You can also see the in period lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, krypton, like that. So, trend in atomic size. Size generally decreases from left to right in a period. Size generally increases from top to bottom in a group. So ionic radius trend. Metals lose electrons, which means more protons than electrons, more attraction. So ionic radius less than natural atomic radius. So nonmetals gain electron, which means more electrons than protons, not as much as attraction. So ionic radius greater than neutral atomic radius. So ionic size depends upon nuclear charge, number of electrons, orbitals in which electrons reside. You can see lithium plus, lithium, sodium plus, sodium, potassium plus, potassium, rubidium plus, rubidium, beryllium 2 plus, beryllium, magnesium 2 plus, magnesium, calcium 2 plus, calcium, strontium 2 plus, strontium, boron 3 plus, boron, aluminum 3 plus, aluminum, and gallium 3 plus, gallium, indium 3 plus, indium. You can see oxygen O2 minus, sulfur, sulfur 2 minus, selenium, selenium 2 minus, tellurium, tellurium 2 minus, fluorine F minus, chlorine Cl minus, Br, Br minus, I minus, like that. So this is very important informations. Now friends, size of ions. Cations are smaller than their parent atom, though the outermost electron is removed and repulsions are reduced. So you can see lithium plus lithium, sodium plus sodium, potassium plus potassium, rubidium plus rubidium, beryllium 2 plus beryllium, magnesium 2 plus magnesium, calcium 2 plus calcium, strontium 2 plus strontium, boron 3 plus boron, aluminum 3 plus aluminum, gallium 3 plus gallium, indium 3 plus indium, like that. So now anions are larger than their parent atom. Electrons are added and repulsions are increased. You know that. Now friends, size of ions. Ions increases in size as you go down a column due to increasing value of N. So you can see boron 3 plus, boron and oxygen oxygen 2 minus. Aluminum 3 plus, aluminum, sulfur is 2 minus. Gallium 3 plus, gallium, selenium, selenium 2 minus. Indium 3 plus, indium, tellurium, tellurium 2 minus. So, from the picture you understand about the size of ion. Now friends, metal versus non-metals. Metals tend to form cations, non-metals tend to form anions. You can see H plus, lithium plus, sodium plus forming cation. Now N3 minus, P3 minus, O2 minus, sulfur 2 minus, selenium 2 minus, lyrium 2 minus, hydrogen 1 minus, F minus, chlorine minus, bromine minus, iodine minus, and noble gases. So backgrounds, electrons can jump between shell, Bohr's models supported by line spectra. The electrons can be pushed so far that they escape the attractions of the nucleus. Losing an electron is called ionization. An ion is an atom that has either a net positive or net negative charge. What would the charge be on an atom that lost an electron? Gain 2 electrons. You have plus 1 because you losing 1 electrons, minus 2 because you gain 2 electrons. So friends, ionization energy, amount of energy required to remove an electron from ground state of a gaseous atom or ion. First ionization energy is that energy required to remove first electron. Second ionization energy is that energy required to remove the second electrons. So group trends, as you go down a column, ionization energy decreases. As you go down, atomic size is increases, less attraction, so easier to remove an electron. Periodic trend, as you go across a period, left to right, ionization energy increases. As you go left to right, atomic size is decreases, more attraction. So more difficult to remove ion electrons. Also, metals want to lose electrons, but non-metals do not. Now friends, ionization energy. It requires more energy to remove each successive electron. When all valence electrons have been removed, the ionization energy takes a quantum leap. So you can see the ionization energy 1, and ionization energy 2, ionization energy 3, ionization energy 4, ionization like that. Now trend in first ionization energy. As one goes down a column, less energy is required to remove the first electron. For atom in the same groups, Z effective is essentially the same, but valence electrons are further from the nucleus. So electronegativity. Electronegativity, tendency of an atom to attract electrons. Group trend, as you go down a column, electronegativity decreases. As you go down, atomic size is increasing, so less attraction to its own electrons and other atoms' electrons. Periodic trend, as you go across a period, left to right, the electronegativity increases. As you go left to right, atomic size is decreasing, so there is more attraction to its own electrons and other atoms' electrons. So you can see the electronegativity trends. So friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.